on a warm morning, 66 million years ago, in a river valley that will one day be called Hell Creek, an unsuspecting world is about to change forever. A tyrannosaur lowers its head to drink, an apex predator unmatched in its environment. Until today, high above, in the pale blue of a perfectly ordinary day, there's a new point of light. It's not the sun or a star, but something much more ominous approaching. This is the last morning of the age of dinosaurs. For 160 million years, dinosaurs owned this planet, adapting into every shape life could hold. But all of that is about to end in one afternoon as that light in the sky reveals its intent. We know the timestamp because of a thin layer of clay found in rock all over the world, laid down at exactly this moment, packed with iridium, a metal that is rare on Earth's surface and common in asteroids. That layer is the fingerprint of the object now falling toward the Yucatán. 12 kilometers across, it is roughly the size of modern-day Paris. That may sound enormous, and standing beside it, it would be. But set it against the planet it's aimed at, and it mimics Mount Everest. A single dark grain hurling itself at 20 kilometers per second, roughly 45,000 miles per hour. This is the strange arithmetic of that afternoon. Something 1,000 times smaller than the Earth is going to change the planet completely. The asteroid is a cratered, iron-dark rock, tumbling, lit hard on one side by the same sun the dinosaurs are standing in. It is coming in at a 60-degree angle, which, as it turns out, is close to the worst possible angle. A steep, shallow sea waits below it, off the coast of what is now Mexico. And then it touches the atmosphere. In a second or two, the rock crosses the entire sky and strikes the sea. The energy released is beyond comfortable comparison, enough to punch a crater 180 kilometers wide into the crust and throw a plume of vaporized rock clear out of the atmosphere. That ejected rock doesn't leave. It rains back down across the entire Earth, and as it re-enters, it heats the sky. For a short, terrible window, the atmosphere itself glows like the inside of an oven, and forests thousands of kilometers from the impact begin to burn. The tyrannosaur in Hell Creek never sees the crater. It only feels the sky turn to fire. How could anyone possibly know what happened in a single afternoon, 66 million years ago? Because of a place called Tanis in North Dakota. There, paleontologists believe they've found the day itself, preserved. When the asteroid struck 3,000 kilometers to the south, the ground rang like a bell. And within the hour, the shaking sent a wave surging up the rivers, not from the ocean, but from the earth itself, flexing. That wave buried fish alive, and in their gills sit tiny glass beads, droplets of rock that were melted in the impact and thrown all the way north, falling back to Earth as the fish were still breathing. It is, if the reading holds, a photograph of a single hour. The animals at Tanis died on the same afternoon our tyrannosaur did, in the same region, under the same burning sky. The fire was only the first act. As the burning faded, a second, slower catastrophe settled in. The impact had thrown enormous quantities of dust and sulfur high into the atmosphere, and there it stayed. A veil wrapped around the whole planet, thin enough to see through and thick enough to matter. Sunlight dimmed, and when sunlight dims, plants stop. Photosynthesis, the engine underneath every food chain on Earth, stalled for months, perhaps years. This is what actually ended them. Not the blast, not the fire. The quiet, sunless winter that followed, in which the largest animals, needing the most food, ran out first. By the time the sky cleared, about 3/4 of all species were gone. At the same time, the asteroid had a rival. On the far side of the planet, in what is now India, the Earth was doing something violent of its own. A region called the Deccan Traps was erupting, not one volcano, but floods of lava spilling across hundreds of thousands of square kilometers, on and off for roughly 1,000,000 years. Eruptions on that scale breathe carbon dioxide and sulfur into the air and swing the climate, and they had already begun before the asteroid ever arrived. So which one ended the dinosaurs? The rock from space, or the fire from below? Scientists have argued it for decades, and to be honest, they still do. But the weight of the recent evidence leans toward the impact as the decisive blow. The same patient curiosity that lets us read a single afternoon out of 66-million-year-old stone is now pointed the other way, upward at a telescope built to catch the oldest light there is and see almost to the beginning of time itself. Next time, what the James Webb Space Telescope actually found.